All right, friends. Today I want to talk about permutations and combinations. There are a lot of videos available on YouTube that go into detail about this topic. So I'm not going to go into too much detail, but just from the perspective of given an interview question, if somebody asks, "Hey, given us, so the idea is behind permutation and combination is the selection. Basically, you have a larger set n, and you want to pick like k subsets out of that, or you want to, well, not k subsets, sorry, you want to pick out subsets of size k out of that. So, in general terms, it's denoted as npk, whereas you have n as the larger set and k is the size of the smaller subsets, and for combination, it's nck. So what let's dive straight into that. So what's the difference between permutation and combination? Basically, the main idea is when you're trying to select a subset, whether or not if the ordering matters. So if you consider the ordering, example AB is different than BA, then that makes a new unique subset, right? So the first thing that we consider is ordering, and then let's denote that by O. And then there is another perspective to that, which is whether or not repetitions are allowed. So what repetition means is, given that I have made a choice for the first element for my subset, whether or not I'm allowed to choose, if I'm filling more than one position, if I'm allowed to choose the same element from the given larger set, that is repetition. So we'll look at it with an example, and will make more sense. So we have basically uh, two pairs that would determine the uniqueness of the given subset from the larger set that we choose, which is ordering and repetition. So let's take a look at each of them. So let's say that would give us one criteria wherein ordering matters, plus means ordering matters, and repetitions are allowed. And then let's say ordering matters and repetitions are not allowed. And then ordering doesn't matter, but let's say repetitions are allowed, and the ordering doesn't matter, and repetitions are not allowed. So if you look at these clearly, when the ordering matters, we are talking about permutations. And when the ordering doesn't matter, then we are talking about combination. So let's understand this with help of an example. Let's say I have a larger set which has two elements here, A and B. So n is equal to A and B. And for the sake of simplicity, I'm going to choose two, the two as a subset size. So I need to choose subsets of size two out of this larger set. So let's consider the first case here, which is where the ordering matters and the repetitions are allowed, right? So what do we mean by ordering matters? When we say, so I have to fill two spots here, right? So which is the size of my subset, right? So k is size two. So for my first spot, if I pick A, right, uh, and if I pick A again for my second spot, that would mean that the repetitions is allowed, right? So I can choose A again, right? Then for my second spot, for my second subset, I can choose A and I can choose B, right? So that would give me another combination. And then for my third subset choice, I can choose B and then I can choose A, right? So if you look at it here, AB, BA are basically having similar elements, but in different order, right? So when we say ordering matters, that means that is giving us two different unique subsets. So that is determining our uniqueness here. And then I can choose B and B again because I'm allowed repetition, right? So right here, case one says that I'm allowed repetitions. So for case one, if you look at it, I have four different unique subsets, right? So it's very important to have the uniqueness property here. So and which is making sense if you look at it, right? So let's say if I have a subset of size two to choose from, and for each of the placeholders, I have two choices to choose from. So and if we multiply two times two, it comes out to be I can get four unique subsets that would well, unique subset, the uniqueness is determined by the criteria that we have defined, which is where the ordering will matter. Otherwise, the uniqueness will go away for this particular case. So for this, we have four choices. All right. So now let's consider if the repetitions are not allowed, right? So if the repetitions go away, then clearly I can't repeat A here. So that goes out for case two here. So this is case two. So that goes out. And here also I'm repeating B again. So that goes out. So, but the ordering is still mattering. So the order still matters, right? So AB and BA are two different subsets, right? Or two different subsets which are unique. So which makes sense, right? So for case two, the total number of choices I have is two. And actually, there is a formula for the permutation, the generic formula that is being used, which is n factorial over n minus k factorial, where n is the largest set and where n is the largest set and k is the smaller subset, which kind of aligns with what we are looking at here. Let's look at the third one here, where now they are saying the ordering doesn't matter whether A, B, B, A. I'm not going to consider them as different. So basically, these two combined are going to give me just one, right? So that would be just one. And they're saying, okay, but you can repeat them as long as you can give me a unique. So A and A are repeated, but they are unique because I haven't selected any more. In the second choice, I have AB, which would give me a unique too. But BA would essentially mean, the AB that is in just reverse order. So that goes away as my choice for third one. So for my third case, I have choice this, and this I can't take. And then I can choose this one again because BB is still unique and I'm allowed repetition. So if you count the number of choices for case three, I have one, two, and three. So I have three choices. All right. Now, let's look at the last case. The last case is where the ordering doesn't matter and there is no repetitions. Clearly, the only choice that I have is this goes away for case four, this goes away, so this goes away, and this goes away for case four. And out of these two, I just get one. So the total number of combination that I get is one. So clearly, with the combination, the number of subset choices are reduced. And I believe there is a generic formula for combinations too, which is n factorial over k factorial and n minus k factorial. And this, if you do the math, it's going to clearly align with what we have looked at, and how these formulas are derived, and how can you come up with the right math behind what we're choosing. There are a lot of YouTube videos which explain them. You can refer to Khan Academy. So let's quickly look at an example, and let's run through the example really quick. So let's say for the case one, I have A, B, C, right? So my n is 3, and k, let's assume that k is also 3, like the subset size is also 3. So if I were to choose out of these, so I can choose A, I can choose B for my first spot, second spot, and for the third spot, I can choose C. So just remember, K is size 3, so I'm supposed to fill in 3 spots here, right? The first, the second, and the third spot. So for now, when I branched out, so this is how I'm branching. I'm choosing A here, and B here, and C here, and at each after I have selected each in each of the branches, I have to remember that I can still choose the A, B, and C again. So here, after selecting the first, I still have my choices, a selection of choices to choose from is A, B, C, A, B, C, and A, B, C. I can still choose. So when I go for the second spot here, so let's say I have to fill 3 spots. So this is the spot that is filled here, and similarly you can have 3 spots here, out of which B is filled here, and you can extrapolate from that. So I've chosen A, and then I can choose A again because repetitions is allowed. So A, B, and C, right? And similarly, for the third spot too, repetitions is allowed. So I can choose A, B, and C, and same thing comes here as A, B, and C, and here also it comes down to A, B, and C, right? And for each of the branches, if you look at, you can clearly see that they are going to eventually turn into three branches at every step, right? So this would turn into three branches. This would give me three and three. And if you add them together, right, each of them is totally giving me nine subsets. So nine here, and nine here, right? So this would be A, B, C, A, B, C, and A, B, C, A, B, C, A, B, C, and A, B, C, B, C, and A, B, C, right? So, and if you try to follow the branches, you would see 27 unique subsets that we have selected. So we'll take a look at this more closely and try to come up with a program how to output these 27 choices in the next video.